Hello everyone and welcome back to my channel. On today's tutorial, I will walk you through all the new features of Gemini 1.5 Pro API. Gemini 1.5 Pro API unlock new use cases with audio and videos capabilities. It supports native audio and includes a new file API to make handling files very efficient. It also added new features such as system instruction and JSON mode to give the developer more control over the model's output. So let's get started by diving into all these new features one by one. In this part, we will talk about system instruction available in Gemini 1.5 Pro API. System instructions enable users to control the behavior of the model according to their specific needs. By providing the model with additional context through system instruction, we can get customized responses tailored to our use cases. Here are some of the tasks we can do with system instruction. We can define a persona or a role, like creating a chatbot person. We can specify the desired output format, like it has to be in JSON format. We can also set the output style and tone, including formality, verbosity, and target reading level. We can also define the goals or rules for the task, like returning just code snippet without explanation. And finally, system instructions are not just for text. We can use them to generate code too. Now let's go to Jupyter Notebook and start seeing system instruction in action. The first step is to install or upgrade Google Generative AI. So we'll say install or upgrade Google-Generative AI. Now the next step is to load the environment variable. I have already generated a Google API key and stored it locally in the same location as this Jupyter Notebook. So we'll say import Google.Generative AI as Gen AI. We are going to import OS to get access to the file server, and then from .env we are going to import load and find to load the environment variable, and then we are going to use load.env find.env override equal true. Next we are going to say os.environ.get Google underscore API underscore key. Then we are going to print a message to the user if the API key is loaded successfully. So we'll say API loaded os.environ.get Google underscore API underscore key, and the condition is not none. Let's run the code, and it successfully loaded the API key. Now let's confirm that we have the right version. So we'll say import Google.Generative AI as Gen AI. I'm importing it again. Then I'm going to say Gen AI.configure API underscore key is equal to os.environ.get Google underscore API underscore key. We are configuring the generative AI to use the Google API key loaded from the environment variable. Now we'll say for in Gen AI dot list models, and then we are going to print all the model name. So let's run the code, and we can see we have the latest version. We have the Gemini 1.5 Pro latest. Okay, now let's see how we can implement the system instruction. First, let's define a system instruction. So we'll say system underscore instruction is equal you are a world expert in climate science. Your responses should be detailed, factual, and cite relevant scientific studies whenever possible. Next, we will define also a prompt. Prompt is equal to what are the main causes of climate change and what can individual do to help mitigate it. Okay, now let's define our model. So we'll say model is equal to Gen AI dot generative model. Model underscore name is equal to, I'm going to use Gemini 1.5 Pro latest. To avoid any spelling mistake, I'm going to copy and paste it here. And for system instruction, we are going to use a system instruction we define above. Next, we will have here a response is equal to model dot generate content, and we are going to pass our prompt. And finally, we are going to print the response dot text. Let's run the code and check the response. And we get the response here, the main driver for climate change and what you can do about it. And as you can see, it's in markdown format. Let's see how we can convert this markdown format. So here we are going to say from ipython.display import markdown, and then we'll say markdown and response dot text. Let's run the code and you see how it's beautiful it is. So we have here the main driver for climate change and what you can do about it: burning fossil fuels, industrial processes, and agriculture. What can individual do as well here? Okay, let's see another example of a different prompt. I have already prepared a sample system instruction. Let me paste it here and comment these two lines. Okay, you are a highly empathetic and motivational life coach. Your responses should be uplifting, encouraging, and focus on personal growth. You should ask open-ended questions to help users reflect on their challenges and goals. The prompt is, I'm feeling overwhelmed and stuck in my current job. I don't know what to do next. So let's run the code. And we get the result. In the final example, we are going to see how we can use the system instruction to generate code. So we'll say here system underscore instruction is equal to, you are a coding expert specialized in front-end interfaces. When I describe a website component, you will return the HTML with any CSS inline to build the component. We don't want to have any explanation, so don't give any explanation for the code. Return the code only. And for prompt, we're going to say, we're going to describe now the component. We'll say a box with borders that contain your underscore name in green, aligned left, and a list of links aligned right. Okay. Next, we'll say here again, model is equal to Gen AI dot generative model, and model underscore name is equal to models slash Gemini dash 1.5 dash pro dash latest, and system instruction is equal to system underscore instruction. Finally, we'll have here response is equal to model dot generate content, and we are going to pass the prompt, and again we are going to print response.text. Let's run the code, and we get the response in HTML format. As you can see here, we have the HTML and the div element here with borders and the inline style. Now if you want to display this in Jupyter Notebook, we can use the IPython display like this. We'll say IPython.display import HTML. Then we'll have here HTML underscore code is equal to, we want to remove the backtick here, this at the beginning, and the HTML to display the element only. So we'll say response dot text dot strip dot remove prefix, okay, 1 2 3, and then HTML, okay, and then we are going to remove also what, the suffix as well, the prefix and suffix, okay, 1 2 3. Finally we'll say here HTML and then HTML underscore code to display the component. Let me scroll up a little bit and let's run the code. And we get the component as we instructed to do. And that's how you can use the system instruction in Gemini 1.5 Pro latest. In the next part, we are going to talk about the new file API. Alright everyone, let's dive into one of the most exciting features of Gemini 1.5 Pro, the file API. This is where Gemini truly goes beyond text. The file API is the bridge that allows us to bring images, audio, and video into the conversation with our AI model. Imagine asking Gemini to analyze a photo, or interrupt a piece of music, or summarize a video clip. That's exactly what we can do now. With the file API, we can upload these different media types directly to the Gemini servers. This opens up a world of possibilities for building multimodal applications that leverage not only text, but the rich information contained in other media formats. Now let's take a closer look at a code example that demonstrates how to work with the file API to upload an image and use it in a prompt. For this example, we are going to use the image of Mona Lisa from Wikipedia. I have already downloaded this image and saved it in the same directory as the Jupyter Notebook. So let's start. So we'll say from IPython.display import image and markdown. Then we are going to display the image from the local file system. So we'll say image file name is equal to Mona Lisa.jpg. Let's run the code. And this is the image that we are going to chat with using the Gemini 1.5 Pro. Alright. Now we are going to use the file API to upload the Mona Lisa image to the Gemini servers. So we will say image underscore file is equal to gen ai.upload file path is equal to Mona Lisa.jpg, and the display name is equal to Mona Lisa. Alright, so here we are using the gen ai.upload file function to upload our image of the Mona Lisa. We specify the local file path and give it a user-friendly display name. This function will return an image file object containing information about the uploaded file, including a unique URI that we will use to reference it. So now if we say print f uploaded file image file dot display name as image underscore file dot URI. Let's run the code. It's now uploading, and then it's going to print the display name and the URI of the image file. And we get the result. This is the display name and this is the URI. Now let's confirm that the file has been uploaded successfully. So we'll say file is equal to genai.get underscore file, and then for name it's going to be equal to image underscore file dot name, and we are going to print retrieved file dot display name as file dot URI. Let's run the code and we get the result. So here we are printing the file display name and its unique URI, which is essentially a web address where the image is now stored on Gemini's servers. This line confirms that the file has been uploaded and retrieved successfully. Now we are going to use Gemini to analyze the image. We are going to create a prompt asking for a description of the image and its historical context. So we'll say model is equal to gen AI dot generative model underscore name is equal to models slash Gemini dash 1.5 dash pro dash latest. Okay. After that, we'll say response is equal to model dot generate content, and we are going to say describe this image considering historical data, and we are going to pass here the image underscore file. All right. It's important to notice here how we pass the image file object, which contains a URI Gemini needs to access the image. Now let's display the result using the markdown library. So we'll say markdown response.text. And we get the result. This is, of course, is Leonardo da Vinci masterpiece. And this is historical information about this image Mona Lisa, which is one of the history's most famous painting, the Mona Lisa, a masterpiece by Leonardo da Vinci. At the end, after we finish with our example, it's always a good practice to delete the files. So we'll say genai.delete underscore file image file.name. Okay, let's run the code. So after we are done with the image, it's always a good practice to delete it from the Gemini servers, especially since it is a large file. This helps manage storage and ensure data privacy. And the file is deleted. So we have just scratched the surface of what's possible with Gemini File API. Imagine what other secrets we could uncover from historical images, art, or even our own photo. In the next part, we are going to talk about tokens in Gemini API. Alright, now we are going to talk about tokens in Gemini API. If you ever wondered how AI models like Gemini actually understand the text we gave them, well, they don't process words as we do. Instead, they break them down into smaller chunks called tokens. Think of tokens like Lego bricks. They are the building blocks of language that Gemini uses to create responses. Understanding tokens is key to getting the most out of Gemini. In this section, we will dive into what tokens are, how Gemini uses them, and why that magical context window is so important. So let's start writing our code. First, we are going to use genai.getModel to fetch the details our Gemini model, specifically the 1.0 Pro latest version. And then we are going to print its input token limit and its output token limit. Okay? So we'll say the following. Import Google.generative AI as gen AI model underscore info is equal to gen AI dot get underscore model, and we are going to choose Gemini dash 1.0 dash pro dash latest. Okay, and then we are going to show model underscore info dot input underscore token limit and model info dot output token limit. So this tells us how much text we can put in the input and how long the model response can be the output. Okay, let's run our code. So in this example, we can see that the Gemini 1.0 Pro model has an input of around 30,000 tokens and output of 2,000 tokens. Now let's print all the model information to see other interesting parameter. So we'll say print model info, and here we can see the model name, the version, the display name, and description, the best model for scaling across a wide range of tasks. This is the latest model, and this is the input and output token as well. Okay, now let's see how we can count the number of tokens in a prompt. So we'll have here model is equal to Gen AI dot generative model, and we are going to take models slash Gemini dash 1.0 dash pro dash latest. Okay, next we are going to say token underscore count is equal to model dot count tokens. You are a fast runner, just as an example. Okay, and finally let's print the number of token underscore count. Let's run the code, and we get the result as a total tokens of 6. Now let's get a bit more complex with the Mona Lisa image. So here we'll say from IPython to display import image and markdown. Then we'll say image file name is equal to Mona Lisa.jpg, and this is a beautiful Mona Lisa picture. After that we'll say model is equal to Gen AI dot generative model, and for models we are going to use as before Gemini dash 1.0 dash pro dash latest. Alright, next we are going to say the following: sample underscore file is equal to Gen AI dot upload. We're going to upload the file again. Path is equal to Mona Lisa.jpg. Okay, and display name is equal to Mona Lisa. Then we are going now to calculate the total tokens. So total underscore tokens is equal to model dot count tokens sample underscore file, and then we are going to print the total tokens. Let's run the code and see how many total tokens we have, and we get the result. The total tokens is 258. As we can see, Gemini can also tokenize images. We upload the image and check how many tokens it takes up. Alright, we can also calculate the tokens needed for the text prompt and the image together. For example, we can say the following: print model dot count tokens, and we can pass an array here. Describe this image as detailed as possible. This is prompt, and then here we'll say sample file. Let's run the code again, and we get the total tokens 265. And that is how we can calculate the total number of tokens. Alright, in the next part we are going to use the file API to prompt with audio. Now for this part we are going to demonstrate how to use the Gemini 1.5 Pro model to analyze an audio file and generate a summary of its content. So let's start. Import Google.generative AI as Gen AI from IPython.display import image markdown. Okay, For the purpose of this example, I have already recorded an audio file and I save it in the same directory of this Jupyter notebook. So here, say audio underscore file is equal to genai.upload file path is equal to sample underscore audio dot am4a. And now we are going to define the prompt. I have already prepared a sample prompt. Just to save time, let me just copy and paste it. We want the model to listen to the audio file and provide a concise summary and identify emotion, intention, attitude, word choice, or delivery style, and also to include timestamps for significant shifts or particularly impactful moments, and try to identify who the speaker is. After that, we'll say here model is equal to genai dot generative model, generative model, and for models we are going to use Gemini 1.5 Pro latest. Then our response is going to equal to model dot generate content, and we are going to pass the prompt and the audio file. Let's run the code, and it is done. Now let's print the response. So we'll say print response.text, and we get the result. The speaker is likely a project manager leading a project planning meeting. They demonstrate a calm, collected, and efficient leadership style, keeping the meeting focused and action-oriented. These are the timestamp, and it extracts also the name of the people in the meeting. Okay, and as you can see, the format is marked down. So if we want to display it beautifully, we can do the following. You can say here markdown and response.text. All right, let's run the code, and that's the result. All right, everyone, and that's a wrap on our deep dive into Gemini 1.5 Pro. We have just scratched the surface of what's possible when you combine the power of AI with audio. From transcribing to analyzing customer feedback, the applications are truly limitless. Remember, Gemini is still evolving, so keep an eye out for new features and models. If you have any questions or cool ideas for audio analysis, don't hesitate to leave a comment below. And as always, hit the like button, subscribe to the channel, and I will see you in the next AI adventure.